That's good. Well, good morning, everybody. Welcome to our session on power plants and boilers. Before we kick this off, Beth has some crucial information she would like to share with all of you. Go ahead, Beth.
Good morning, everyone. Thank you for joining us today. Just a quick announcement. As you probably know by now, our two regional seminars are coming up just a few weeks here. Our Southern California seminar will be on September 15th in Long Beach, and our Northern California seminar will be October 20th in Fairfield. We will have opportunities to take the MECH exam at both of those seminars. It is unfortunately too late to register to take the test at the September 15th seminar in Long Beach, but there is still time to register if you want to take the test at the October 20th seminar in Fairfield. The deadline to register for that is September 15th, and you do have to register and pay directly with MECH to be able to take that test and be on the test roster. So if you're wanting to get certified and you want to take that exam, and you need information on how to get registered, either visit the MECH website, mech-certification.org, or reach out to me and I can help you get set up. And I'll put my information in the chat box so that you have it.
Great. Thank you, Beth. That's good information for them. You know, it's important to make sure you, like you say, get registered early. Don't procrastinate and be late on it, because I know that you're studying hard to be ready for this test. And without further ado, I'd like to start off with our next slide here. So just to kind of go over some of the criteria that we're trying to cover today, is that we're going to look at the characteristics of steam, the types of steam and piping systems and functions, how steam traps work, basic water treatment, how infrared testing is used, the function and use of pressure reducing valves, that heat is measured in BTUs and what that is, and how energy generation operates, and how to safely fire a boiler. Not too much detail on that. That'll be by the manufacturer's recommendation, but we'll kind of cover some of that. How condensate systems function, and the various type of steam valves. And we'll finish up with how to look at the efficiency of a boiler can be improved. Just a brief touch on that. Next slide, please. Now, looking at a thermal power plant. So we kind of put this together, looking at how things run through. And, you know, a lot of times we generate steam, and we use steam to turn a turbine, which can turn a generator, which can produce electricity. We can also use that steam for other processes within the plant as well. Next slide, please. So I wanted to make sure that, you know, one of the questions that comes up a lot of times is what's the difference between a water tube boiler versus a fire tube boiler? So I wanted to list this up here. So if you look at the one on the left of your screen, that is a water tube boiler. And it literally is as described. Water flows through a tube in a fire chamber. And so the fire is around those tubes of water. If you look at the one to the right, that is a fire tube boiler, and the fire actually comes through the tubes, which heats up the body of water. So two totally different ways and means of looking at that. Next slide, please. When I throw this in here pretty much every time, these are great notes that our good friend Angel put together. He says, when you take the test, take your time. Read and reread the questions. Eliminate two of the worst answers. Bring a non-programmable calculator. Very important. You cannot use your phone. And don't be worried about 80% of the questions are from working in healthcare. Okay? And you get 2 hours. Mark the ones that you're iffy on and come back to those if time remains. But always make sure you answer the question. The next slide, please. So we look at the power plant and boiler. So I'll just read this off. There are many good reference materials that are out there that you can go to different libraries to get additional information on. And some of those are listed there to the right. It's high pressure boilers, Stearns and Foss. There's also Boiler's Operations Guide, and there's also Armstrong's Steam Trap book. That's a good one. So make sure and do a little more homework other than just attending this class. There's a lot of information on power plants and boilers that's out there. Next, please. Going over the objectives, already have these, kind of hit those again, but just for your reference, really focus on characteristics of steam and the type of steam piping systems and how steam traps work. It seems like there's a little bit more information on that for the test questions. Next, please. So the characteristics of steam, it's produced from water, of course. That sounds very intuitive, but it's clean, it's odorless, and it's tasteless. So you can't. A lot of times you'll smell impurities, but pure steam, you don't smell that. Easily distributed and controlled. So if you think about a steam line, you can send a lot of energy down a steam line quite a distance there. Heat can be used over and over, meaning that I can use it from a very high use temperature use to even a lower temperature use. That's something with steam. It's once you produce it, there are multiple uses for it. High usability of heat content. So when you think about steam, the amount of energy that's in steam is significant, and that's significant compared to water. And we'll explain that a little bit more later. It gives up its heat at a constant temperature. That's important to know when you start looking at charts. I'll show you a little bit of that in here, I think. And then the well-known characteristics of steam, if you were just to list out the three, it's going to be pressure, temperature, and volume. Next slide, please. The types of steam. So you have dry, superheated steam, and that's greater than 100 degrees centigrade. You have saturated steam, which is at 100 degrees C, and these are at atmospheric pressure. You have wet steam, which is unsaturated, and you'll see why those two are right on the same line here a bit. And water, of course, is below 100 degrees C, and ice is at 0 degrees C. When you're looking at the Celsius scale, it's all about water. From ice to water to steam. That's the way the scale is written. Next, please. So here's the chart. And so this is the temperature and pressure chart when you look at how they go through three different phases. So you go from, see where it says the triple point right there at the very bottom left-hand corner of the chart. At that point, you're looking at that temperature and at that pressure, you're right at the cusp of transferring from ice, either from ice to saturated water as a liquid or into the vapor side of it. As you go up in temperature and go up in pressure, you go to what's called the critical point. And that's the upper right-hand corner there. The critical point is where it makes that transfer into supercritical water and also superheated steam. So you'll have that there. Next slide, please. Types. So when you look at the types of steam piping systems and functionality, if you look at the bottom left-hand corner, you'll see the boiler that's there. So the boiler, it's taking water in, and then it's heating that water up to produce steam. The steam travels vertically up through this chart to the steam header. The steam header is where the steam lines are distributed throughout the different systems that they're attached to. So you can have it attached to heating units, sterilizers, other food service, all different kinds of uses for steam. If you look to the right of that, you'll see what's called the heating unit, and that's where you're using the steam for transfer of heat to, it could be heating a space as such, and or it could be for food service or such. To the right of that, after it goes through, it's used up all of its heat, the steam then condenses in through the steam trap, right? So the steam trap is going to take a little bit of steam, because the steam goes through there, it's now steam, and it also has condensed is called condensate. And we'll get into a lot more detail on that. But the condensed line, which is the liquid that comes off of that steam, the condensate, then is collected. If you go down that line, you'll see it's in the condensate in a receiver tank. So now we're taking something that's in a vapor state is now into a liquid state again. And after it's in the liquid state again, it's in the receiver tank. And then from that liquid state, it goes to a feed water pump, which then pressurizes that back to the pressured vessel, which is the boiler, to receive the water to heat it back, create steam again. So that's the steam cycle running through this on this particular one. There's other components that are in the system, which is the de-air tank and chemical feeds, but we'll look at that a little bit later. I wanted to make sure that you had a little broad overview and make sure that when we're going through this course, we're teaching it at a level to where those have no idea about steam and steam use, all the way up to those that are, stationary engineer in a plant will have a lot more knowledge of this, and hopefully this will refresh back what could be on a test for the MECH exam. Next slide, please. Here's a steam trap. And a steam trap is the self-contained valve, which automatically drains the condensate from the steam contained through the enclosure, while remaining tight to the live steam, or necessarily allowing the steam to flow at a controlled or adjusted rate. Most steam traps will also pass non-condensed gas while remaining tight to the live steam. So if you look at this steam trap that's it's illustrated here, you can see the steam is in the red, where it's coming, from the left, it's coming down and it's coming into the chamber. It's also leaving that chamber. But what's also leaving that chamber, you see the ball that's in the bottom there. When the condensate, which is the blue, fills up enough, that ball floats up and it allows that condensate to flow out of that steam trap. And that's what you see going to the right, flowing out of the steam trap and back to that condensate line. That's what we showed you in the slide before, how that water, that condensate goes back to the boiler. And we'll have more on this here in just a second. Next slide, please. So here we go for the basic water treatment for boilers. So if you look to the bottom left-hand corner over here where it says feed water, this is feed water coming in. And so it's the makeup water, and then you have makeup water as treatment. So you're treating that water. So you're trying to remove the oxidizers that are in there, because you don't want to have, a high oxygen content, because then you'll have corrosion occur into your system. So the makeup water treatment, we'll get into a little bit of that, a little bit more of it, but I want you to see the simplistic form of it. So it's feed water to makeup water treatment. From makeup water treatment to the right of that, you're going back into the boiler. And from that boiler, you're heating that up. And of course, it becomes a gas, it becomes steam. From steam vertically up from there, going straight up with the red line that you'll see, it goes over, it's utilized, you'll have some losses or usage of that. And once that's done, you'll have the condensation of it, and it'll return back as water. You can see that going straight back down. So you're not retreating that water so much as you're treating new water that's coming in to make up for those losses. And if you look at the very bottom right-hand corner there, you'll see what's called blow-down water. So as you keep running water through the system, it also builds up a little bit of contaminants that you would like to remove from your boiler. So if the boiler filled up with contaminants, just like your hot water heater at home, you need to blow that down, purge that out. Otherwise, you'll have a buildup and you'll lose efficiency. And that's what we were referring to in the first slide, the efficiency of that boiler as well. Next slide, please. So this is looking at how infrared testing is used for steam. Infrared testing can be used for more than just steam. It can be used to spot things that are hot, and things that are hot, some things are supposed to be hot and some things are not. So if you have a bad electrical connection, The infrared will show that there is heat generated due to that poor connection that's in electrical circuits. With steam systems, if you look at the drawing to the right, you can see from the thermal camera areas that are hot and areas that are not. So if you were to use an infrared, you can look at a steam trap and see if it is collecting the condensate, or is it just blowing steam through it and you're doing a loss. So that can also indicate whether or not the ball that's in there is not operating or it's stuck or whatever. But the infrared is a very good, useful tool for indicating whether or not the condensate systems are working properly. Next slide, please. So this one is, looking at the function and use of a steam pressure reducing valve. And I try to make this simplistic. A lot of times you'll see this steam reducing station, which could have several of these valves in it, to actually take a high pressure steam and drop it to a lower pressure and even mid pressure. So I've seen, multiple headers in place with multiple steam pressure reducing valves and redundant valves in case something happens to one. We can switch to the other and repair one. So this valve, if you look at the line coming from the left, it's the high pressure side. And as it goes into that valve, it reduces that through a mechanical mechanism that reduces it down to a lower pressure. And that's to the right of that. You can see that as indicated on the gauges that are there that are above it as well. But it's important that you know that these valves have a function, and how that function is to reduce that pressure. The next slide, please. So, I've heard this a lot. I've had questions in the past. What's a BTU, right? It's a British thermal unit. And, what does that mean? Well, it's the amount of energy needed to cool or heat 1 pound of water by 1 degrees Fahrenheit. Remember, we talked about Celsius earlier. Now we're talking about the Fahrenheit scale. So the British thermal unit uses the Fahrenheit temperature scale, and it is the amount of energy needed to cool or heat 1 pound of water 1 degrees Fahrenheit. And this can be tricky, but once you think of British, think of Fahrenheit, and hopefully you'll remember this piece of it. This could be definitely a test question. Next slide, please. So looking at how an emergency generator operates. So without getting too complex, I went ahead and looked at if you look at the section to the left, it says the emergency generator is a backup of electrical system that operates automatically with the loss of normal power, normal utility power. Within seconds of the loss of normal power, an automatic transfer switch, which you'll see to the right, senses the loss of power and commands the generator to start, and then transfer that electrical load from the generator. And the standby generators usually begin by supplying power to certain circuits. And so if you look at those components to that generator, you have a radiator, of course, and you have exhaust manifolds, you have the engine, you have expansion joints for exhaust, you have a turbocharger a lot of times, but it's all connected to a generator, that piece of it right there. And then, of course, you have batteries to start it as well, and a control panel. And to the right, I wanted to make sure that I showed this, especially in healthcare, that we can have several automatic transfer switches that transfer at different times. So it doesn't transfer that load all at once to different circuits. It can be delayed out to the most critical. It happens first. In healthcare, we want it with less than, I think it's less than 10 seconds, of course, but you have other loads that you want to have it brought on. And when you get into complex systems, you can have what they call load add and also load shed. But I wanted you to see this piece of it here, that there's an automatic transfer switch. Now, there'll be the acronym for it is an ATS, that those are put in place downstream from the power coming from the emergency generator. Next slide, please. This is looking at how the condensate system functions. We saw some of that, with the steam line and everything. This will give you a little bit more detail. That the condensate system includes anywhere that steam is condensed from the liquid water, right? So if you look at the bottom left-hand corner, you can see an illustration of a boiler. Thinking of a flask with a flame underneath it. It's heating up water and it produces steam. As it goes through the steam piping system, listed in orange, for those that you can see this in color, it can have a drop leg, which you see on the first part of it there, which it has a steam trap, and it allows for the condensate to flow back through the blue line, which goes all the way back to a water receiving tank. If you look down a little bit further, you can see another process. Process number one is using that steam. If you could think of it as a steam kettle in a kitchen, it's using that steam to heat and cook, to heat water, to heat food, and to cook food. And once it utilizes the energy from that steam cools and it becomes a condensate, and that condensate is a liquid, and it runs back to a steam trap, which you see in green there. And that steam trap then flows that condensate back to the condensate main line, which is in the bottom at a left to right slope, back to the water receiving. And the same thing for process number two. And also at the very end of that, you see another dead leg there where it's collecting that as well. You notice too on the right, bottom right, where it's receiving the water, it also has a vent off of that to let off the escaping gases that might be in there as well. And then, of course, then that liquid needs to be pumped back to the same pressure, of course, or a little bit higher to get back into the boiler. So you'll see it go over to what you see is the boiler feed water, and that's where we can add chemicals within there, dosing, and you'll see a dosing tanks and stuff out there as well. But it still needs to get pumped back up to that boiler pressure, and you'll see that pump right next to it as well. Next slide, please. These are the different valves for steam. One of the things to always keep in mind with steam valves, they're very specific. And if a valve is not closed all the way, you can have what they call steam cut, of course. And the steam is very abrasive. It can literally cut notches within the metal within the valve. So either the valve is open or it's closed unless it's made to throttle. And so there's different types of valves for different things. Open and closed. A lot of times you'll see globe valves, you'll see gate valves, you'll see ball valves, non-return valves, which is kind of like the backflow valve, right? You'll see needle valves, which have unique, specific usage for that, for measuring flow out. Butterflies, pressure relief valves. These are to relieve pressure. If it overpressurizes, how do you relieve that pressure? So it's a pressure relief valve. And you have a plug valve and a strainer valve. Strainers can remove impurities that are there within that system. And of course, you have the diaphragm. So these valves are all valves with different applications. What I'm trying to illustrate here is there's not just one steam valve. There's multiple valves that can be used within the systems, and they need to be appropriate for the system application that you're using that for. And the best way to look at that is from the manufacturer. They'll have a lot of very specific information on how and what valve to use for which application. Next slide, please. So this is a test question. I didn't want to have you guessing at what the answer might be. I thought I'd list this out, but I want you to look at this. The principal functions of a steam trap is, and the first, remember we talked about eliminating two of the possibilities that wouldn't make sense, and you get down to you got two choices, and it's usually pretty easy to figure out which one is the right choice. When you look at it, remember the first opportunity or option is question A, which is it equalizes the pressure on the steam line. Remember we talked about a steam trap. It has nothing to do with pressure, right? It has to do with what? Removing the condensate, and that condensate is a liquid, which is water that accumulates in the steam line. So the correct answer is B. It's not C, which is to control the distribution of steam to various pipelines in the system. That sounds like a header, right? And if you look at steam by releasing, having a set amount of steam that's regulating the pressure, that's not a steam trap. That's a different use. Next question here, which I looked at for 82, it says, what should you do as the first step when removing a steam trap strainer from the system? Of course, you want to shut it off. Think about safety. When you look at these, when you're operating on the systems, think about the questions. They're going to focus on the safety aspect of it. And of course, when you look at option A, which is be sure that it is dirty, well, of course, that doesn't make sense, right? You eliminate that one. Have a replacement handy. It's probably not a bad idea. So that's a possible. And C, be sure there's enough line pressure. Well, that's not right. You don't want to have line pressure. So you kind of eliminates it back down to B and C. And of course, for safety, you'd want to be C. You want to shut the line off before that you start to work on the steam trap. Next slide, please. Now, this is going back to the infrared readings and how they're used. And so the infrared tool is a very versatile tool. It can be used to measure heat. It can identify bad connections. It's also used to diagnose steam traps. We kind of went over that in the first part of our lecture today. So it's all of the above. So the infrared tool can be used to measure the heat, identify bad connections, and also diagnose steam traps, whether or not they're functioning. Question listed as 84. Boilers with a flat surface exposed to pressure tend to bulge or warp, right? And that's just like, if you think you're inflating something, right? And so it's inflated with pressure. What is the proper name of the support or the device that prevents that warping? I would not expect a lot of people to actually know that the answer is a stay. And so stays are used to keep that flat surface down, unless you really get into this. But if this ends up being on as a test question, just think of stays. You can look at, rods, but the rods is not the correct answer. It's the stays. Support arm, that's not going to keep something from bulging. Header, that's the distribution side of it. So the correct answer is stays, B. Next slide, please. So one of the questions on there says a Scott's marine boiler with a burner and the stack located at the front end is considered it's a double pass boiler. This is the correct answer. So I went ahead and pulled up a illustration of the Scott's marine boiler. So if you look at that at the very bottom, you'll see where the flame is coming out. That's one pass. That's going that direction. And the second pass is actually going back towards where that flame originated from. So it's two passes in this body. And so when you look at a Scott's marine boiler, it's a very common design. It's out there. You'll see quite a bit of that that's out in the field. So a Scott's marine boiler is a double pass boiler. It's not a triple, it's not a single, it's not a quad, it's a double pass boiler. Next slide, please. So this one, I wanted to remember we talked a little bit about, there's a water treatment, right? And so one of the things you're going to look at, we talked about blowing down a boiler. So that's the hardness of the water with the minerals that are in there, right? So we're going to, says how is the hardness in a boiler water expressed? And so I wanted to make sure that you had, a lot of times water softeners will be in grains, but the boiler hardness is expressed in parts per million. So just so you would be able to help visualize this and remember it, to the top right, I have the total hardness. And if you look at ppm, that's parts per million, that's the top scale that you have there. And where it says 0, 25, 50, 120, 250, and 425. and the colorimeter side of this scaling. So that hopefully will help you remember how the hardness in a boiler water is expressed. Not in your water softener at home, but in the boiler water is expressed. It's in ppm. The next question is the height of the water in a boiler sight glass should be, and the correct answer is halfway up the sight glass. So anytime that if you were designing something, wanted to put a gauge on something, you would try to get something where the normal operation is pretty much in the center, right? If it's on a dial gauge, you'd want it right at 12 o'clock. So you can measure what's below it or what's above it. The same thing with the sight glass. So the halfway up that sight glass is where that water level should be. And different manufacturers will have different explanations. But for the test questions, this is pretty good solution, I guess, or answer for this question. This is halfway up the sight glass. Higher than, listening to the questions of higher than any part of the boiler, well, that wouldn't make sense. Then you'd have no steam in the boiler, right? You'd have it just full of water. Converting half of the top roll of the tubes. Now that doesn't make sense either. 2 inches from the top of the sight glass. Why would you do that? That's, again, that would not be a very good measuring instrument if most of it was used up within there. So the correct answer is halfway up the sight glass. Next question, please. So this one, it says, if the supply of makeup water to a boiler was cut off, the main protection device that would shut the boiler shut it off safely would be, and the answer is a low water cutoff. And so I wanted to make sure you have a good visual on this. It's not thermal overload. It's not the pressure relief valve. Pressure relief valve won't shut it off. It just relieves the pressure. Thermostat system, that's not doing it. It's a low water cutoff if it's all about the water. And so to your right, you will see a low water cutoff. You can see that there's a float that's in there. So when the water level gets too low, it's going to indicate, it's going to switch there, right there, and it's going to send electronic controls to shut the boiler off. It wants to shut it off. That's a safety. If this thing failed and you had low water, you can imagine that you could, end up in a overpressurization for the system. The relief valve would be going off, and you could run the boiler, of course. So this is what that is. It's a low water cutoff is what's used. Next question is, when a boiler is equipped with a gate type blow off or blow down valve and a cock or quick opening valve and the same blow off connection, which valve should you open first? And the answer, of course, is the lower one, right? It's the quick opening valve there that you're going to open that up. You'll see that, you see one of them in the illustration to the right. It says the blow down valve, but you'll see these two in there. But of course, this is a test question, but always go by, the or manufacturer's design or the engineering design for it. But for this question, look for the quick opening valve is the correct answer. It's not a gate type blow off valve. It's not. It's neither a valve at the same time, right? It's neither valve. This operation requires another operation. That's not correct. It's a quick opening valve. You'll see that in the illustration of the board as well. Next slide, please. So this question is low pressure steam is considered. This is actually a question that is a lot of people ask this in the field as well. What is low pressure steam considered? In this test question, it is anything that's 50 pounds or less. 50 pounds or less is low pressure is the answer for here. There's there's low pressure, there's medium pressure, and there's high pressure. Different pressures for the different steam systems. Next question is, steam carries more heat, and the answer is than water, right? So we talked about the amount of heat. Heat is energy, and steam has a very large thermal capacity, more so than water. The other answers, possible answers, is because it is a vapor. It does. It's a vapor, but that's not quite it. What is it is released outside? No, that's not it. Condensate, no. It carries more heat than water. Is the answer. Next. I think that is it. That's what we have for steam plants. I know a steam plant is a very quick one as you go through the system, not getting too far into the weeds on it, but I wanted to make sure that people were aware of some of the overviews for steam systems, not get into too much of that. Was there any questions? Phil, hopefully you have at least one question for me this morning.
Not a question. I just, again, want to point out that it's a national test. So for instance, on the question about pressure, a lot of people take the LA exam, and LA defines pressure, low pressure, as 5 pounds or less. Right. But we're not doing LA. Right.
No, we're doing the national side of it. It's a very good point. I'm glad you brought that up. I was going to mention that earlier. But yeah, on we do see a lot of large boilers here, but it has to be a very large requirement for steam here in California. Steam in California, the first time I came to California, we talked about California specials, which I had no idea what that was until later I found that, it's a lot of small package boilers, right? And I'm like, wow, why'd you do that? They said, well, we don't have to have, all these station engineers out here. I'm like, that doesn't make sense. You're making a very inefficient system just to save some labor, right? So I don't think it really traded off, but that was my opinion, and it didn't matter too much to the system. They were there. But you're right, yeah. When you look at these test questions for the MECH, it's for the national. It's not specific to California. And we have to keep that in mind. Any other questions? Dave Lockhart. Dave, can you come up with a good question for me this morning?
First of all, Charles, thank you very much. That was an excellent presentation. Love the pictures and the illustrations. Really helped to send the message home to everybody. The one thing, and it's really not a question, but it's more of just information, is on the condensate system. People may ask, and I don't know if it's a test question or not, but why the heck do we return condensate to the boiler? We've made steam already. It's just condensate. What the heck? Why would we return it? And it's exactly, Charles. It's value money. We've already treated it. We've heated it. We've cleaned it. I mean, it's clean water because of making the steam out of it. And it's incredibly important that we bring that treated hot water condensate back to our system to save some very significant money versus retreating fresh water, heating that fresh water, and putting that back in the system. So in your plants or at your facilities, sometimes folks will just, let's just dump that condensate and not worry about returning it. But it's a big value, money savings to bring that condensate back. So I loved your illustrations you showed there, and it's an important product that we use. I see Mike's got my thumbs up too. So yeah, great presentation. Lots of good stuff. The one thing that you got me on, and I'm sure you reviewed those answers with that, on that blowdown, I was thinking that gate valve, because it's kind of a protection thing, that the gate valve got open first, and then you did your quick open, and then you made sure that gate valve was closed. So that was a new one on me. So that was good.
Yeah, and really, that was the answer to the test question, a sample test question. But it also, the illustration would help you as well, right? So you would like to have, when you look at that process, it depends on where they put it. And so it's not as intuitive, right? So it depends on the design, put it in, and the specs that are for that, which one you would open first. But for that test question, that's what they put.
Interesting.
So I'm like, oh, yeah.
Yeah, because I would think the gate valve was what protects that quick open in case it actually got open. You'd open that first, do the blowdown, and then close off that gate valve. But interesting. Very good. Great topics, great questions, and hopefully those on the call learn something, or maybe somebody else has a question. Nice job.
Thank you.
Charles?
Yes, sir.
Charles, could we go back to that question, to the picture that you have with that?
I don't think there was a picture of that. They had a picture of the shutoff valve, which had one valve only on there. That's it. They didn't show
Exactly.
two. Yeah,
Exactly.
They only showed,
I think the question referred to a bottom blow where you
right, exactly.
typically-
Which
and,
is not that. It's on the bottom of the boiler itself. If you go actually to one more, not there, next one, go again. One more, one more, not there, not there, not there. Right, go back one. So I know this was, go back one more, I think, Beth. One more right there. So if you look, so that blow down would be on that, well, they didn't even show it here. They show the valve at the bottom right-hand corner there. But the blow down valve itself, like Dave was saying, there's two valves in there. You have the gate above, which protects that one at the very bottom. So I didn't put a good illustration on that one there. I guess I could have added that to it. Probably would have given way to it, but yeah. But yeah, where the question's at, it actually is not showing the blowdown valve for the boiler. It's just actually the release from the shut off, right? So
yeah, this is again a difference between what LA asks on their boiler tests and what they're asking on this national test. The national standard would be you always use that quick opening valve to get that quick pulse that clears the debris off the bottom of the boiler. Whereas on the LA test, the answer they want is that you open the inboard valve versus the outboard valve. The outboard valve is used to protect the inboard valve. So it's
different,
again,
right? We
exactly.
do things a little bit different in California, that's for sure. You know.
Yes, we do.
Texas, you know, when we look at the boiler licensure in Texas, there's actually 3 levels that you have, and so they have a 1, 2, and 3, and you have to have experience with those larger boilers. So it's really tough for you to get those other different licensures. So
yeah, we have 3 levels here in LA also.
Do you? Okay.
Almost nobody gets the lowest level. It's pretty useless.
Right. Yeah, that's true. Well, one thing that Dave mentioned, I'd like to note, I don't think it'll help you on kind of on the test here, but water treatment, you know, we talk about treating condensate coming back. And a lot of times the water treatment is what we refer to as dosing. We have a dose that frequency and amount that we put into that water treat. And if you think about a lot of that, it's not treating per the condition of the water as much as when you go do your labs, you say, okay, I need to do this, I need to do that, it gets it back to it. But that constantly adjustment of it for the needs of those chemicals, there are more complex water treatment systems out there. But most of the hospitals I would go to would have just a dose meter. It was set up once a week, or they'd come through and they'd go, oh, okay, the water treatment guy or gal would say, you need to do the following. So even though we're doing a lot of testing, there was not a lot of adjustment. And the reason why I bring that up was just like Dave mentioned about that condensate return. I had to do an investigation of a boiler that failed. And as you get into the more efficient boilers, the tubes that you see in there, those tubes are thinner and thinner so they can transfer that heat quicker, right? And more efficiently. And so they're very susceptible to having oxidated water in there that will pit them very quickly. So to make sure that you have enough oxygen scavenging that's happening in your chemical treatment, dosing, what happened to these boilers, they literally, they had a condensate return line fail. So you had more makeup water coming in than you normally would. The dosing didn't keep up with it. And when they took this boiler out of service, you know, going from winter to spring, they didn't need all of these multiple boilers. they shut it down and what we call laid it up with this water that's in it that has a high oxygen content because it was just dosing the water treat. It actually had a greater need for more water treatment than chemical than it actually received, and therefore it actually went to boiler. And that is in that case it was your tax dollars or our tax dollars that actually went away, right? And so they had to buy new boilers. And so my research was to find out why, right? So that's what we came up with. It was actually a broken condensate return line that caused the failure of the boiler. Recommendations would be a more active measures of providing that water treatment, which is going to a more automatic feeds that would regulate by the need, not by just a pre-prescribed dosing. Does that make sense? Hopefully so. I might save a boiler in this little 2 minutes I drew out here. So who knows, Dave? You never know. So I know Dave and one of the things that I know we'll let everybody, we have a few minutes. So one of the things that we're actually, that's being a push that's for healthcare is to go to removal of fossil fuels and actually go to all electric, right? And so for us, old boiler operators, it's kind of like a cardinal sin, right? We love our boilers, it's like we love our generators. So I think boilers, you'll see more and more efficient boilers that are coming out, but there's definitely a push for electrifying as using electricity as the energy to create steam and to do other processing. So I don't know. We'll see how long the boilers last. Maybe, I doubt they get rid of them in our lifetime. I don't think I'll live that long, but we'll see. So, well, great. Well, I appreciate everybody tuning in today. Hopefully you've learned something and or take something away from it. And I look forward to seeing you, I guess, at the next opportunity. So best of luck. Don't forget, register for that test. You can't pass the test, and you can't take the test if you don't register. So you got to register, you got to go online. Any questions, Beth will guide you through that. Those that haven't registered, I will hopefully see you here in the North California conference, I think October 20th. It's going to be a great conference. I'm looking at the lineup of who's coming to it, so it'll be exciting. I know you'll be, studying away and thinking about this test, but I think once you get the test done, you'll get to really enjoy that conference. You'll have a good time. So look forward to seeing you there. And with that, I'll say bye. Dave, thanks for coming in this day. And Phil,
thanks, Charles. Nice job.
As well. Yeah.
Thank you, Charles.
Thank you. All right, great. Thank you.